In this video, we'll practice stoichiometry calculations using the chemical reaction for exploding gummy bears. Stoichiometry relates the amounts of any two substances in a balanced chemical equation. As a conversion factor, the stoichiometry step is a mole-to-mole ratio that uses the balancing coefficients to compare substance 1 to substance 2. For example, if we look at the exploding gummy bear reaction, we can compare sucrose and potassium chlorate as 1 mole of C12H22O11 to 8 moles of KClO3. Each numerator or denominator of the conversion factor must have three parts: the value from the balancing coefficient, the units, which are moles, and the chemical formula for the substance. The values in the stoichiometry conversion factor are exact. They are not measured values, and so we ignore them for sig figs. How the conversion factor is positioned depends on the given information in the problem and which units and substances need to cancel. As always, we let the given information guide us. Stoichiometry serves as a bridge to connect the two sides of the problem: what we know about substance 1, grams or moles, and what we're trying to calculate for substance 2, which could be grams or moles. Stoichiometry is necessary. Without it, you cannot relate the two substances. One more thing, this comparison can be between any two substances in the balanced chemical equation. Either substance can be a reactant or a product. You can compare two reactants, two products, or one of each. The only thing that matters is that you are comparing two substances. As a reminder, substance 1 is what we know. Information is given in the problem. Substance 2 is what we're trying to calculate. We know that the stoich step, shown in the red box, is required, no matter what. But how do we know if we need to use molar masses? It's actually pretty easy to figure out. Look for grams in the problem. If grams are given for substance 1, you'll need its molar mass to convert from grams to moles. If grams are calculated for substance 2, you'll need its molar mass to convert from moles to grams. How many molar masses you need depends on the specific problem. So let's work some problems. All of the examples are based on the chemical reaction of exploding gummy bears. Basically, what happens when potassium chlorate is heated, then decomposes to produce oxygen gas, and reacts with the sucrose in the gummy bear. Let's take a look at the periodic table and note any molar masses that we may end up needing. Carbon is 12.011, hydrogen 1.008, oxygen 15.999, potassium 39.098, and chlorine 35.45. In our first example, we are given 0.0911 moles of potassium chlorate and are asked to calculate moles of water. This means that KClO3 is substance 1 and water is substance 2. Neither substance refers to grams, so we don't need any molar masses here. It's only the stoichiometry step, and this stoich step will compare these two substances, KClO3 and H2O. So we start with what we're given, 0.0911 moles of KClO3. Now, because mole of KClO3 is in the numerator, we'll need moles of KClO3 in the denominator of our stoich conversion factor. This means that moles of water will be in the numerator. We pull the numbers from the balanced equation, so we have 8 moles of KClO3 and 11 moles of water. We'll cancel our units and then check our sig figs. We have 3 sig figs in the original value. Stoich is exact. And so our final answer will have 3 sig figs. So when we do the calculation, 0.0911 times 11 divided by 8, we get 0.125 moles of H2O. In this example, we are given 0.380 moles of CO2 and we'll calculate grams of KCl. CO2 is substance 1 and KCl is substance 2. Here, we do need a molar mass for KCl because we need to calculate grams. We do not need a molar mass for CO2 because the amount was given in moles. Calculating molar mass for KCl, we have 39.098 plus 35.45 equals 74.548 out of the calculator. The fewest decimal places is determined by chlorine. So we need to keep 2 decimal places in our molar mass calculation, and that gives us 74.55 grams per mole. Starting with what we're given, we have 0.380 moles of CO2. In our Stoich step, we'll need moles of CO2 in the denominator in order to cancel, which means moles of KCl is in the numerator. It's worth mentioning here that the Stoich step is always mole to mole using the balancing coefficients, even if you want to calculate grams. So we have 12 moles of CO2 and 8 moles of KCl. We'll cancel the units and then set up for our next step. Now we apply molar mass as a conversion factor. We had moles of KCl in the numerator, so we need moles of KCl in this denominator. That means grams of KCl will be in the numerator. Placing the numbers, we have 1 mole in the denominator and 74.55 grams in the numerator. Checking sig figs, we have 3 sig figs in our original value. Stoich is always exact, and we have 4 sig figs for our molar mass. So our final answer will be rounded to 3 sig figs. Doing the math, we have 0.380 times 8 times 74.55 divided by 12 gives us 18.9 grams of KCl. In our third example, we are given 26.39 grams of CO2 and are asked to calculate moles of sucrose. CO2 is substance 1 and sucrose is substance 2. We are given grams of CO2, so we'll need its molar mass. Because we're calculating moles of sucrose, we won't need its molar mass. So then to calculate the molar mass for CO2, we have 12.011 plus 2 times 15.999 gives us 44.009. Setting up the problem, we start with what we're given, 26.39 grams of CO2. Then we'll apply our molar mass conversion factor to convert grams to moles. Since grams of CO2 is in the numerator, we'll need grams of CO2 in the denominator of the molar mass conversion factor and moles of CO2 in the numerator. We have 1 mole and 44.009 grams. We'll cancel our units. And then for our stoich step, since moles of CO2 is already in the numerator, we'll need moles of CO2 in the stoich denominator, which gives moles of sucrose in the numerator. And then our stoich values are 12 moles of CO2 and 1 mole of sucrose. Cancel our units, and then check our sig figs. We have 4 sig figs in our original value, 5 sig figs in molar mass, and stoich is exact. So doing the math, 26.39 divided by parentheses 44.009 times 12, close out the parentheses. Reporting to 4 sig figs, we end up with 0.04997 moles of sucrose. In our final example, our sample is a 5-pound gummy bear. So we're given 1340.16 grams of sucrose and are asked to calculate grams of KClO3. Sucrose is substance 1 and KClO3 is substance 2. Here, we're following the entire path from grams of substance 1 to grams of substance 2. So we need molar masses for both. For sucrose, we have 12 times 12.011 plus 22 times 1.008 plus 11 times 15.999. Rounded to 3 decimal places gives us 342.297 grams per mole. For potassium chlorate, we have 39.098 plus 35.45 plus 3 times 15.999 equals 122.55 grams per mole, rounded to 2 decimal places because of chlorine. To set up this problem, we start with what we're given, which is 1340.16 grams of sucrose. The next step is our molar mass conversion factor. Because we already have grams of sucrose in the numerator, we have to place grams of sucrose in the denominator, so the units will cancel. That means moles of sucrose will be in the numerator. Filling in the values, we have 1 mole and 342.297 grams. We'll cancel the units and then set up our stoichiometry step. Here, the denominator will be moles of sucrose in order to cancel with moles of sucrose from the previous step. That means the numerator units will be moles of potassium chlorate. We have 1 mole of sucrose and 8 moles of potassium chlorate. We'll cancel our units and then set up our next molar mass conversion factor. Since we have moles of KClO3 already in the numerator, then in this conversion factor, moles of KClO3 will go in the denominator. That means grams of KClO3 will go in the numerator. The values then are 1 mole and 122.55 grams. We'll cancel our units and then check our sig figs. We have 6 sig figs in the original value, 6 sig figs for molar mass of sucrose, Stoich is exact, and we have 5 sig figs for potassium chlorate. So our final value will have 5 sig figs. When we do the math, 1340.16 times 8 times 122.55 divided by 342.297, we get 3838.5 grams of potassium chlorate.